When the base of a power is a product, meaning we are multiplying two or more factors together, we're just going to go ahead and apply the exponent to each factor. So for example, 3n raised to the fifth power is 3n times 3n times 3n times 3n times 3n. And you can see that we are multiplying 3 by itself 5 times, and n by itself 5 times. N times n times n times n times n. It's really important that you understand the difference between this case, where the coefficient is in parentheses, so 3 is being raised to the fifth power, and here where the coefficient is not within parentheses. This means we just have 1 3 times n to the fifth, so times n times n times n times n times n. 3n to the fifth, no parentheses, only has 1 3. It is not 3 to the fifth power. This rule, this power of a product rule, applies when one or more of the factors is itself a power. So in this case, we will just go ahead and apply the power rule to each of the factors. For example, x squared times y to the fourth raised to the fifth power. We're going to use the power rule to raise x squared to the fifth power and y to the fourth to the fifth power. So I'm going to multiply those exponents, x to the 10th and y to the 20th. So we could have just directly done x to the 2 times 5 is x to the 10th, y to the 4 times 5 is y to the 20th. The most common thing to forget is that if there is that coefficient within the parentheses, you are going to apply the exponent to it. So 13 squared, x to the 4 times 2, x to the 8th. If there is no exponent, you can either just think of tacking on that exponent to it, or you can think of it having a power or an exponent of 1. So y to the 1 times 2 is y squared. And this is a reasonably sized number, so we would go ahead and write 169 x to the 8th y squared. Here, a to the 3 times 10, a to the 30th, so power rule for each factor. B to the 70th, and C to the 20th. Again, recognizing this invisible exponent of 1, C to the 6th, so 1 times 6, 6, D to the 5 times 6, D to the 30th. It will come up again and again that we have an invisible coefficient of -1 or an invisible factor of -1. So here we actually have -1 times x to the third squared, which gives me -1 squared times x to the 6th. So -1 times -1, with that -1 being in parentheses, is +1. That means this evaluates or simplifies just to x to the 6th. So -1 times -1 is +1, making that disappear. In this case, we have -1 times x to the third raised to the fifth power. Now, -1 to the fifth is going to be -1 times -1, +1, times -1, which is -1, times that fourth -1, which is +1, and then when we multiply -1 by itself 5 times, we end up with -1. So -1 times x to the 15th. That gives me my final simplified expression of -x to the 15th. So the key here is recognizing when there's a negative within the parentheses, we have a factor of -1, which we need to raise to the exponent given.